So this is a little video to help with the My iMaths exercise called Solving Graphically. It's all about solving simultaneous equations graphically, and I'm going to start with question 1, match the graph. So it says here are the graphs of 3 equations, match each equation to the letter shown on its graph. So I'm going to go over to my notepad now. So first of all, a little preliminary reminder about the relationship between equations and the graphs that represent them. So often you see an equation written in the form y equals something x and something on the end, and in that form it's quite easy to draw the graph because the number on the end tells you the intercept. So the +5 on the end tells me that my graph is going to cut there at 0, 5, and then the number in front of x tells you the gradient, or how steep it is. So the 2x tells us that the graph is going to have a gradient of 2, which means that for every 1 across, it's going to go up by 2. Across 1, up 2. Across 1, up 2. Across 2, up 4, if you like, to save a bit of time. Back 1, down 2. Back 1, down 2. Back 1, down 2. Back 2, down 4, if you like, to save a bit of time. And they should all lie on a straight line. So, very easy to get from the equation to the graph. Let me just label that y equals 2x plus 5, and that saves you having to make a whole table of x and y values where you calculate lots of points and plot them all individually and then join them up. As long as you know where it cuts and how steep it's going to be, then you can do that very quickly. Okay, so that's that, but however, sometimes you might see an equation that is written in this sort of format with the x and the y both on the same side, both on the left hand side in this case. Now you could rearrange the equation, do things to both sides, keep it balanced until you got it into the form y equals something x plus something, like the previous one, but there is an easier way to do this. And the easy way to do this is to think about what happens when x and y are 0. So I'm going to start by thinking about what happens when x is 0. So if x was 0 here, then this 2x would disappear and we would have 3y equals 24. And to make that balance, y would have to be 8. So when x equals 0, y has to be 8 to make the whole thing balance. So that means it goes through the point 0, 8, which is there. 0, 8. When x is 0, y is 8. Now I'm going to think about where it crosses this axis. So this is the x-axis, but it's where y equals 0. So if I think about when y equals 0, if y was 0, then the 3y bit would disappear, and you just have 2x on the left and 24 on the right. So if y was 0, then x would have to be 12 to make that balance. So when x equals 12, y is 0, and that tells you that it cuts the x-axis at the point 12, 0. So when y is 0, x is 12, and that gives you a point on the x-axis. And then with 2 points, you can easily join them up, and that is the line that represents the equation 2x plus 3y equals 24. So if you take any point anywhere along that line and get the x and y values of that point, stick them into that equation, it should come out to be 24 every time. Okay, so that was the preliminary work, and that's going to help us with the My iMaths equation, My iMaths exercise rather. So here is question 1. It says match the graphs. Here are the graphs of 3 equations. Match each equation to the letter shown on its graph. And then it's got these equations. So what I'm going to do is get my pad and try and make those graphs myself. Okay, so the first one was 2x plus y equals 4. I'll just write that over here. 2x plus y equals 4. Now, if x was 0, y would have to be equal to 4 to make the whole thing balance. So that tells me that the graph of that goes through the point 0, 4. If y was 0, you'd get 2x equals 4, so x would have to be 2 to make that balance. So if x is 2, y is 0, that makes a pair, so it tells me that it goes through the point 2, 0. Let me just recap on that. So it goes through the point 0, 4, because x equals 0 and y equals 4 makes this balance. But it also goes through the point 2, 0, because x equals 2 and y equals 0 makes that balance. So now that we've got the 2 points where it goes through the axes, we can carefully join them together, and I'm trying to kind of check the gradient here, so it's kind of 2 across and 4 down between them. So I'm kind of trying to continue going 2 across and 4 down, because using that very thick pen it's kind of very easy to get something that doesn't quite stay in line. Okay, so that is the line of the equation 2x plus y equals 4. Now the next one on the list was 4x minus 3y equals 18. So if y was, let's say if x was 0, then you'd get the 4x would disappear and you'd get minus 3y is equal to 18. So if you divide both sides by minus 3, you see that y would have to be minus 6 for that to balance. So when x is 0, y would have to be minus 6 to make it balance. So I'll just plot that as a point on the graph. It's actually a bit further than I've drawn the axes. So when x is... no, it isn't, because it's down here, isn't it? So when x is 0, y has to be minus 6. So that's the point 0, minus 6 down here. When x is 0, y has to be minus 6 to make that balance. So it goes through the point 0, minus 6. What about if y was 0? So if y was 0, then the minus 3y bit would disappear and you'd just have 4x equals 18. If I divide both sides of that, I would get x by 4. I would get x equals 4.5. So when y is 0, x has to be 4.5 to make it balance. So that gives me the point here. Let me just do a little line there. So x equals 4.5 when y equals 0 balances the equation. So now that we've got 2 points where the line crosses the axes, we can join them together, and that gives us the line of the equation 4x minus 3y equals 18. Okay, the last one was 2x minus y equals 12. So if y was 0, now let's start with when x is 0. If x was 0, you would just get minus y equals 12. Or in other words, y equals minus 12. So when x is 0, y has to be minus 12 to make that balance. So that's actually all the way down here on my axes. 6, 7, 8, 9, 10, 11, minus 12 is down there. Okay, so the line's got to go through the point 0, minus 12, which is there, because x equals 0 and y equals minus 12 makes it balance. Now I'm going to think about what happens when y is 0. So you just get 2x minus 0 equals 12. So the y bit would disappear. 2x equals 12. X would have to be 6. So when y equals 0, x is 6 to make that balance. When y equals 0, x is 6, so it goes through the point there, 6, 0. When y equals 0, x has to be 6 to make it balance, giving me that point. So, join those together, and we get the straight line of the equation 2x minus y equals 12. So we've done 3 straight lines. It's just a question of matching them up to the ones on screen now. So 2x plus y equals 4. That was the blue line here. So I'll label that with A. 4 minus 3x equals 18. That was the orange line here. So I'll label that with B. And then 2x minus y equals 12. That was the red line here. So I'll label that with C. So in fact, on this occasion, it's turned out to be ABC, which you might have written if you were guessing anyway. But never mind. So the last bit says use the graphs to solve the simultaneous equations. So you've got 2 simultaneous equations, which are 2 of the ones we've already mentioned. 2 of the equations already mentioned. So it's 4x minus 3y equals 18, which is represented by the orange line, line B. And then you've got 2x plus y equals 4, which is A, which is represented by the blue line. So there is one pair of xy values that works in both the first equation, or the orange line, and also the second equation, the blue line. And it's basically where the 2 lines meet. Yep. So all of the points on the blue line are representing solutions to the blue equation. All of the points on the orange line are representing solutions to the orange equation, but there's only one point where they meet each other, which gives a solution that works in both equations. And in this case, that's the point 3 minus 2. So x equals 3 and y equals minus 2 should be the solution. Let me just fill that in there. X equals 3 and y equals minus 2 should give you the solution that works not just in the first equation, not just in the second equation, but both equations at the same time. And in fact, before I click mark it, I can check that, because I can stick those numbers into each equation and see if we get what we are supposed to get. So the first one, 4x, so that would be 4 times 3 is 12, and then minus 3y, so that would be minus 6. 12 minus 6 is 18. And then 2x plus y, so that would be 6 add minus 2, and that does make 4. So that should all check out. Let's mark it. 10 out of 10. Lovely.